Assalamu alaikum. Today we are going to study paper 1. Okay, this is a multiple choice questions. The code is 5070 O levels chemistry 11. In October November 2018, this is the paper for 1 hour. So let's move towards the first question. A student titrates aqueous sodium hydroxide from a burette with dilute hydrochloric acid in conical flask. What he does, he titrates sodium hydroxide from the burette, okay, and dilute hydrochloric acid is in the conical flask. Conical flask and the dilute hydrochloric acid hai. After titration is complete, the conical flask is emptied. What is the correct procedure before the next titration? What we have to do before the next titration? So rinse out with the conical flask with the sodium aqueous sodium hydroxide. If we rinse it with the sodium hydroxide, so it will be basic. Rinse out the conical flask with the dilute hydrochloric acid. If we rinse it, then it will become acidic, so we will not get the accurate reading at the end. Rinse out the conical flask with the distilled water. Yes, this is the absolutely right, because distilled water has pH 7, so it seems correct. Use the conical flask again without rinsing. No, we can't use it. Okay, again without rinsing. So this is not correct. This is also not correct. This is the correct answer. Okay, this is also not correct. Question number 2. The result of paper chromatography experiment are shown. X is an aqueous solution of the salt of group 1 element, and Y is an aqueous solution of the salt of transition element. Okay, so this is the salt of transition element. This is the salt of you can say the first group. Okay, lithium, sodium, potassium, rubidium, cesium. Its salt is here. Okay, so they are taken up by the solvent. Okay, so what happens? Which row is correct? Large RF value. What is the RF value? RF value is equal to the distance traveled by the solvent. Sorry, distance traveled by not solvent, by the solute. Okay, first is by the solute, and divide by distance traveled by the solvent. Suppose we consider it, this is the 5, distance traveled by the solvent is the 5. I'm just supposing it. Okay, it's not the exact quantity. I just want to tell you that this is same for both of them, and it has traveled, you can say that 4 millimeter, centimeter, and it has traveled 3 centimeter. So this will be 3 by 5 and this will be 4 by 5. Which one will have the large RF value? This will have the large RF value. Okay, and this will have the small RF value. So this is clear that larger RF value goes to Y. Okay, it cannot be A, it cannot be B, it will be from C and D. Now requires a locating agent. Why we need locating agent? Actually, locating agent is to visualize the colorless substances which have been separated, but we can't see them. So to visualize them, we spray the locating agent and they become colorful. So you must know that transition elements are colored, so we don't need to use a locating agent for them. So which is colorless? X is the colorless. Okay, so Y and then X. So C is the correct option, because we need to distinguish it, we need to make it visible by using the locating agent. Y is already visible because it is the colorful. This belongs to transition elements, and compounds of transition elements are already colorful. So that's why we don't need to use the locating agent for Y. Okay. Question number 3. A substance dissolves in water to form a colorless solution. The solution reacts with the aqueous silver nitrate in the presence of dilute nitric acid to give the yellow precipitate. Okay, so you must know that solution reacts with the aqueous silver nitrate, whatever the substance is we want to see. Okay, so that reacts with the silver nitrate AgNO3. Okay, and yellow precipitates are formed. You must know that yellow precipitate are formed by the silver iodide. Okay, this is solid. Okay, so it means the anion must be iodine. So chloride cannot be there because it forms the white precipitate and it also forms the white precipitate. So we are going to skip them. These are not correct. Now next is the calcium iodide and the iron iodide. Okay, what is the possible identity of the substances? So here is actually what we take. We have the calcium iodide. Okay, because iron iodide, it has some issue that it itself is green in color. It is colorful. Okay, so that's why this is the colorful this is the colorless solution is only found with the calcium iodide. Okay, and if you have iron iodide FeI2, so when you dissolve in the water, this is definitely ionic compound, plus 2 it has charge, it has minus, means it is the ionic compound, it will get dissolved in the water, but it will give you green color. Okay, you know that Fe plus 2, these are the from the transition block transition element, so it gives the color, so that's why it doesn't form the colorless solution. So when we look at the colorless solution, okay, so then calcium iodide seems the appropriate answer. Okay, you can say that calcium iodide, this is the colorless solution. Okay, and this is the aqueous solution, means AgNO3 aqueous. So Ag to AgI, okay, and then becomes calcium nitrate, which is the soluble. Okay, so yellow precipitate is formed of the calcium silver iodide. Which statement are correct? The volume of gas at constant pressure increases as the temperature increases. It's okay. Volume is directly proportional to temperature according to Charles law. The rate of diffusion of the gas increases as the temperature increases. That's also okay. How? That when the temperature increases, kinetic energy increases. When the kinetic energy increases, so diffusion also increases. Okay. So the rate of diffusion of the gas increases as the temperature increases. It's okay. The pressure of gas at constant volume decreases. The pressure of gas at constant volume decreases as temperature increases. No. When the temperature is increased, so kinetic energy is increased. When the kinetic energy is increased, so their collisions are increased. When the collisions are increased, so ultimately pressure is increased instead of decreasing. Okay, so this is wrong. The pressure of gas at constant volume is constant. So what about pressure? That decreases as the temperature increases. No, it's that increases as the temperature increases. Okay, so this is wrong. 1 and 2, these two statements are correct. So option B is correct. Okay, which row shows the number of the particles in S? Okay, S16, 34 and minus 2. So now let's see S16, 34 minus 2. So what we have to see? First we have to see number of protons. Proton is equal to, this is atomic number, is equal to 16. Then number of electrons. Electrons are equal to protons, but here we have charge minus 2. It means it gained 2 electrons, so we also add them. It becomes 18 electrons. Okay. Then neutrons. Neutrons is equal to mass minus atomic number minus atomic mass, you can say minus atomic number. Okay, so atomic mass is 34 and atomic number is 16, so what we get? 18. So 18 neutrons, 16, 18 electrons and 16 protons. So protons are 16, it's okay. Protons can never be 18, can never be 20, because protons number do not change. Okay, then neutrons are 18, this is going right, and electrons are also 18. Okay, so neutrons are not 16, those are the 18, so this is also wrong, so option B is correct. Which substance has a giant covalent structure at room temperature? Methane, you know that this is the simple. Okay. Sand, SiO2. You have studied about its structure. It looks like it resembles diamond. Okay. This is a giant structure. Sodium chloride, it has not covalent structure, it has ionic, okay, but not giant. You can say it is in the crystalline form. H2, it is also covalent, but it is the simple structure, means HO, oxygen, and H. Okay. While in case of silicon, you know that it is in this way arranged. Okay. So it resembles diamond. It is in tetrahedral form, non-conductor of heat and electricity. Magnesium oxide has the high melting point. It is used to line the inside of furnace that operate at high temperature. So why does magnesium oxide have the high melting point? Definitely it has, because it has melting point. No, it don't have melting point, metallic bond. Sorry, it has metallic bond. No, it doesn't have. It has strong forces between its molecules. It doesn't have molecules. It exists in the formula in the crystalline form, and it has the formula unit to represent it. It's not molecular because it is not covalent, so that's why it can never be molecules. Okay. It is a simple molecular substance. No, not at all, because it doesn't have covalent. So how it can be molecule? It is an ionic compound. Of course, this is an ionic compound, and ionic compounds have high melting point. Okay. What is the dot and cross diagram of NCl3? So now let's see. Actually, you have to see what is, and N is the nitrogen. It has 7 electrons, 2 and 5. Okay, outermost it contains 5 electrons. So now you can see that whether nitrogen has 5 electrons. We are just showing here the outer electrons. Okay, nitrogen has 1, 2 and 3, which are sharing by the, you can say, cross, and here it has to be here lone pair of electron, but it doesn't have, so that's why it is wrong. It has how many electrons? 1, 2, 3, 4, 5. It's okay. Nitrogen has 5 electrons. What about chlorine? Chlorine has 17 electrons, and it becomes 2, 8 and 7. Outermost it has 7 electrons. 1, 2, 3, 4, 5. 5 dots are there, 2 are missing, so that's why it is also not correct. You can see here that nitrogen has 5 electrons, 5 crosses are there. It's okay. And chlorine, how many? 1, 2, 3, 4, 5, 6, 7, and all chlorines are 7. Okay, one is sharing between the chlorine and nitrogen, and 1 electron of nitrogen with the chlorine. In the same way, 3 nitrogens are being shared with the 3 different chlorine, and 1 lone pair is there. So this is the correct. Okay. Here, same as here, that the number of electrons in the outermost shell of the chlorine are 7, but here are 5. In the same way, the number of electrons in the outermost shell of the nitrogen are 5, but here is 3. So that's why it is not correct. So option C is correct. Two properties of metals are given. It is malleable. Malleable means it can be converted into the sheets. Okay. It conducts electricity, of course, because it has the free electrons. Which of these properties are due to the layers of positive ions being able to move? The conductivity is because of the free electrons. It has no concern with the movement of the positive ions. But malleable means when we hammers any metal, so it converts into sheet, and its positive uh, ions, you can say, which are called the cations or metallic cations, slide over each other. So it explains the only one. Okay. What are the relative formula masses of 1 mole of solid magnesium and 1 mole of hydrogen, 1 mole of chlorine? Magnesium is 24, and chlorine Cl, it doesn't exist as it is in the atomic form, it exists in the molecular form. 35.5 multiplied by 2, it becomes 71. So 24, this cannot, magnesium cannot have 48, cannot have 12. 12 is its atomic number, not the masses. Okay, so it doesn't exist as the atomic form, so that's why this is also incorrect. Option C is correct. Complete combustion of hydrogen Hydrocarbon produces only carbon dioxide and water. Okay, and this is related to stoichiometry, and we can easily do it. When 0.1 mole of hydrocarbon, okay, is completely combusted, which volume of carbon dioxide is measured at room temperature and pressure? We take here the ratio method. We have to find the volume of the carbon dioxide produced by the combustion of this much number of moles. So now let me tell you the ratio method. C2, sorry, this is not C2, C5 and H12 ratio carbon dioxide. If it's 1 mole is consumed, so 5 moles of carbon dioxide are produced. Okay, so if it's a 0.1 mole of hydrocarbon is used, 0.1 mole, okay, what will be its amount? Now let's see it. X is equal to 0.5. Okay, the amount of the moles of the carbon dioxide produced will be 0.5. Now volume we have to find. 1 mole is equal to, sorry, volume, mole and volume, mole ratio volume. We know that 1 mole contains 24 dm cube, and if we have 0.5 moles, so what will be the amount of the volume in dm cube? So X is equal to 24 multiplied 0.5, it becomes 12 dm cube. Okay, so here we get the 12 dm cube. This is the answer. What is observed during electrolysis of aqueous copper sulfate using carbon electrodes? A pink solid is deposited on the anode. An anode solid is not deposited on an anode. Okay, so bubbles form on the negative electrodes. Bubbles form on the negative electrodes. Now let's see where the bubbles are formed or not. Okay, let me tell you that copper sulfate in the aqueous form contains Cu plus 2 cation, and next is SO4 minus 2. This is the cation. Okay, anion, and the second cation is H plus because this is the aqueous, and OH minus, this is the aqueous. So water also converts into its ions. Okay, H plus and OH minus. So now you can see what will be observed on the using the carbon electrodes. A pink solid is deposited on the anode. No, here you can see that on the cathode what happens. On the cathode, this is the carbon. On the anode what happens? On the cathode, from both of these cations, copper will be reduced. Okay, it will gain 2 electrons from the cathode, and in this way copper will be reduced. So reduction takes place on the cathode. That's why we call it CR, reduction on the, and on the anode oxidation takes place, and it will never be oxidized. Okay, so 4OH, this is the very famous equation. 4OH release all of their 4 electrons, and it becomes 2H2O and plus O2. So 2H2 is the liquid, no issue, and the O2 is the gas which is released. Okay, so what happens on the anode? Gas is released. Now let's see. A pink solid is deposited on the anode. Pink solid copper is deposited, of course, but not on the anode, on the cathode. That's why it is the incorrect. Bubbles form a negative. Bubbles form on the negative electrode. Yes, on the negative electrode, that is the anode, which has negative or positive. Sorry, this is the positive, and this is the negative. This is also incorrect. Okay. The color of solution fades. Yes, this thing happens because copper is being deposited on the cathode. It is going to be, the solution becomes dilute as the electrolysis proceeds, so its color fades. Okay, because copper sulfate has the blue color. Copper sulfate has blue color. Okay, and when its concentration decreases, because the cathode is taking the copper, okay, and it's going to be decreased in the solution, so it's going to be dilute, so blue color has to be fades. Okay, it has to be faded. The negative electrode becomes smaller. No, it has no concern with the negative electrode, it is not used. Okay, so C is the correct option. Electrolysis is used to plate a metal statue with the silver. The statue is an electrode in the suitable electrolyte. We have a statue that has to be electroplated with the silver, okay, to make it means silvery and to give it good appearance. So you have studied about the electrolysis, what we do. Anything which has to be electroplated is made the cathode, and the substance which is going to be deposited on the other, okay, is made anode, or you can say that solution is used. Its solution is used. So cathode statue will be on the cathode, not on the anode. Okay, and the next thing is that with silver we need silver. Okay, silver chloride aqueous and silver nitrate is used to plate a metal statue with the silver. The statue is an electrode in the suitable electrolyte. Which row is the correct? Cathode is made as statue, and then we have the silver chloride and we have the silver nitrate. So silver chloride, actually this is not aqueous. Okay, silver chloride is insoluble. Its electrolyte is not formed. So that's why silver chloride is insoluble and it gives the white precipitate. Okay, so that's why it's not possible. Silver nitrate is okay. Where statement about the exothermic reactions are correct. Energy is absorbed from the surrounding in endothermic. Yeah, of course. Energy is absorbed from the surrounding. This is correct. Energy is released to the surrounding. No. Energy is not released to the surrounding in the endothermic process. That takes place in the exothermic process. Incorrect. The temperature of the reaction mixture falls. Yeah, of course. That's why energy is absorbed from the surrounding. Temperature of the reaction mixture falls. The temperature of the reaction mixture rises? No, it takes place in exothermic when the temperature increases, so it is released in the surrounding, okay? And when the temperature is decreased in case of endothermic, so it is taken from the surrounding, okay? 1 and 3 are okay. The equation represents the reaction between the two gases X2 and Y2 to form the compound XY. You can see that these are two gases which are reacting to form the next gas. The energy profile diagram for the reaction. This is the reactant and this is the activation energy, and the product is found. This is which type of reaction it is. Energy is on the higher level. Reactants are on the higher energy level and products are on the lower energy level. So this is the difference. Okay. So reactant actually have to come here. So I think this is the exothermic. Okay, because this energy which is being used over here is compensated here. Okay, so they cancel each other. So this difference means to us. Okay, so base statement about this reaction is correct. The activation energy for the reaction is equal to E. Activation energy is not E. Activation energy is actually starts from here. Okay, from here till here. Okay, the barrier to the reactants is this one, not from here. The enthalpy change for the reaction is equal to E. This is not enthalpy change. Enthalpy change is this reactant products. This difference is enthalpy change. Okay. The reaction is exothermic. Yes, this is right. That reactants are on the higher level, and as they convert into products, so heat is released. Because products are on the lower level, so this is called exothermic. The total energy needed to break the bond is greater than the total energy needed to form the bonds. No. If the energy needed to break the bond is greater than Y, this is the less. Then it has to be here, and products have to be above it. Okay, this is also incorrect. It's an exothermic. Its sign will be negative. Okay, in kilojoule per mole. The equation shows the reaction for the manufacture of ammonia. You can see here the equation. Which change will decrease the activation energy of the reaction? Which change will decrease the activation energy of the reaction? Okay, so addition of catalyst. Yeah, this is the main thing which only decreases the activation energy of the catalyst. It lowers the activation energy barrier. Decrease in temperature? No, not at all. Increase in concentration, not at all. Increase in pressure, no, no, no. These have no effect on the activation energy. Activation energy is the barrier, okay? And when we use the catalyst, it provides an alternative pathway, and this way activation energy barrier is reduced. And in this way, many reactant molecules, or you can say reactants, are become able to cross it, okay? And in this way, the rate of reaction is increased by the decrease of activation energy, okay? That happens because of catalyst. When the bismuth chloride is added to the water, a reaction occurs and a white precipitate of bismuth hypochlorite is formed. Okay, which changes increase the mass of the white precipitate formed. Yes, we can see here that adding more water, does it affect? Of course. When we add more water, okay, this is the reaction and this is at equilibrium, or you can say that this is at equilibrium. When we add more water, so by addition of more water, the concentration of reactants is increased. So in this way, the equilibrium will be shifted towards the right, okay, from the more concentration to lower concentration. In this way, more white precipitate of the BiOCl is formed. So adding more water, this is okay. Adding aqueous sodium hydroxide, is it beneficial? Now let's see, I think sodium hydroxide, it's not beneficial. Okay. Adding dilute hydrochloric acid. Yes. Adding dilute hydrochloric acid. Hydrochloric acid, HOCl. So here is aqueous sodium hydroxide. Actually, aqueous sodium H plus and OH minus. Okay. And sodium hydroxide Na plus and OH minus. Basically, H plus, OH minus, and these OH minus, actually they increase the concentration of H plus and OH minus over here. In this way, reaction is shifted towards the right, okay, because of the common ion effect. What is common ion effect? Means the concentration of water, you can say, simply is increased, okay, aqueous. And the secondly, from the sodium hydroxide, this is from OH, also comes from here. So in this way, concentration is increased, so it shifts to the right, okay, and more precipitate of bismuth, you can say, chloride is formed. Bismuth hypochlorite is formed. So dilute hydrochloric acid, HCl, but here is chlorine, so there is something dilute, okay. This doesn't provide as much efficient, okay, precipitate, because this is, here is HCl already. So if we HCl provide, so this reaction will be shifted backward, okay. We provide, if we add the HCl, so HCl, it will increase the concentration of H plus over here and Cl minus over here, so it will help to start the reaction in the reverse direction. Instead of increasing the concentration of this precipitate, it will decrease. So that's why we don't use the HCl. So using the adding water and adding dilute adding the aqueous sodium hydroxide, these both are beneficial. So that's why option A is correct. 1 and 2. Next question. Calcium carbonate reacts with the dilute hydrochloric acid to produce a carbon dioxide. It's okay. The carbon dioxide is collected using the apparatus. The reaction is done 4 times. For each reaction, 25 gram of the calcium carbonate and excess of hydrochloric acid are used. 25 gram of calcium carbonate and excess of hydrochloric acid. Okay, which reaction will fills the gas syringe with the carbon dioxide in the shortest time? Means the rate of reaction will be fast. Okay, lumps of calcium carbonate with 1 mole per dm cube of the hydrochloric acid, and the lumps of calcium carbonate with a 2 mole per dm cube. Now let's see that if we have hydrochloric acid and its 2 moles are here, okay, then those are more preferred because the concentration of the hydrochloric acid is greater, so that's why rate of reaction will be fast. So now let's skip 1 and 3. Now let's see lump of calcium carbonate, and here is the powder of calcium carbonate. Powdered, in case of powdered, the surface area is increased. In case of lumps of calcium carbonate, the surface area is not increased. So that's why when we have calcium carbonate 25 gram and in the form of powdered, so it has more surface area, and surface area is directly proportional to rate of reaction. Okay, and if we have greater number of moles, okay, more concentration, so concentration is also directly proportional to the rate of reaction. So simply we can say that option D is correct and B is also incorrect. Okay, because here is the lumps, surface area is reduced. Question number 19. Many reactions involve oxidation and reduction. Which statement is correct? Acidified magnesium manganate ion change color from the colorless to the purple when reduced. Okay. Acidified manganate ion change color from the colorless to purple. No. From purple to colors. Okay. When reduced, its oxidizing agent itself is reduced, but the color has the problem. Okay. All the reactions that involve oxidation also involve reduction, which involve the oxidation also involve the reduction. Okay, this is okay, means that any type of reaction which involves the oxidation. So meanwhile reduction is also taking place, so that's why it is called redox reaction. Okay, this is the correct option. During a reaction, oxidizing agent lose electrons. No, if they lose electrons, so they themselves are oxidized, and when they themselves are oxidized, so how can they oxidize other? They have to gain electrons to reduce themselves, and in this way the others will be oxidized. So that's why it is incorrect. Reduction is the loss of hydrogen. No, reduction is the gain of hydrogen. So option B is correct. Three separate mixtures of solution and a solid are made as shown in the table. The mixture are warmed. In which mixture does gas form? Three separate mixtures of solution and a solid are made as shown in table. So if we react sodium hydroxide with the ammonium chloride, so ammonia gas will release NH3. Okay. So reacting with the alkali, this displacement reaction takes place and ammonia is released. If we react with the NH4 twice SO4 and 2 HCl, hydrogen chloride gas will be released. But this is the soluble. This is a HCl is soluble, so it won't be released. Okay. Let me tell you, if we have H2SO4 and NH3, NH4Cl, so you will gain NH4 twice SO4, okay, and 2 HCl will be formed. 2 HCl, when it is in aqueous, so 2 HCl won't be able to take out from here, won't be released, it will get dissolved, so no gas is formed. Okay, but here let me tell you the first reaction, NaOHO, it reacts with the NH4Cl. What will form? NaCl, Na and Cl. Okay, NH3 and one hydrogen, and with OH it will form the H2O. Okay, and NH3. NH3 is the gas, it will be released. Okay, so here is no gas in case of reaction with the Mg plus H2SO4. Yes, in this reaction you will find MgSO4. Okay, salt plus acid plus metal, salt plus gas, that is the hydrogen. So this is released. So hydrogen is released and no gas is released. Okay, so option B is correct. NH3 is released. Okay, no gas is released, and here hydrogen is released. Question number 21. Insoluble salts are prepared by the reacting aqueous solution of the soluble salt. A precipitate forms. Which pair of the aqueous solution form a precipitate? Barium chloride and nitric acid. BaCl plus HNO3, BaCl2. Okay. So what will be formed? Barium nitrate, BaNO3 twice plus 2HCl. This is also soluble in water, and this is also, all the nitrates are soluble, you know, from the solubility table. Okay. Barium chloride, BaCl2 plus sulfuric acid, H2SO4. What will be formed? Barium sulfate, which is insoluble precipitate, will be formed, and then 2HCl. This statement is correct. Barium nitrate and nitric acid. Barium nitrate, BaNO3 twice plus nitric acid, HNO3. So no reaction will be taking place. Okay. Barium nitrate, BaNO3 twice and sulfuric acid, H2SO4. What will be formed? Barium sulfate, BaSO4. This is also insoluble. The state will be formed. 2 hydrogen and 2 nitrate, 2HNO3 will be formed. That is aqueous, which is soluble in water. So 2 and 4. This is not here. No precipitate is formed. No reaction is formed. Okay, and here no precipitate is formed. All are soluble in water. So aqueous. Okay. 2 and 3. 2 and 4. Sorry. 2 and 4. The diagram shows the main stages in the manufacture of ammonia-based fertilizer. Okay, so you can see nitrogen, hydrogen, they are compressed and passed from the iron powdered at the 500 centigrade. Okay, and you get here the ammonia, which is the 15% almost, 10 to 15%, and rest of the hydrogen, which is unreacted, has to be given back, and then that ammonia can be used with the next reaction to form the fertilizer. Okay, what is happening in the process labeled X? Yes, here the hydrogen, basically hydrogen and nitrogen, which are unreacted are recycled. Okay, are given back, and then they are again compressed and passed from the hard iron powder, so that they may convert into the ammonia. What's happening in the process labeled X? Ammonia is returned to start the process to shift the equilibrium towards the product. No, ammonia is not shifted at all. It's separated. The gases are cooled to cause ammonia to form the liquid. It doesn't take place over here. Unreacted hydrogen only is recycled. No. Unreacted hydrogen and nitrogen are recycled. Yeah, of course. Both of these gases which are unreacted are sent back, compressed, and passed through the iron powder, which is hot, and ammonia is formed. Next. What is the use of sulfuric acid? Bleach? No, it doesn't bleach. Food preservative? Yeah, of course. Manufacture of detergent? No. Manufacture of vanadium oxide? No. How can it produce vanadium oxide? No, it's impossible. It's used as a preservative to preserve the food. Which property shows an increasing trend in the elements from the group 1 to group 4 and across a period of the periodic table? Ability to form anions? Yeah, of course, it seems, because anions, metallic character decreases. First of the metals, then non-metals, this decreases. This in the number of electron shells remains constant in that period. Reactivity of the water, that also decreases. Okay, metal oxides are more reactive than the non-metal oxides. Sorry, metals are more reactive. Metals react with the water and non-metals don't react. Okay, when we move from here, I mean to say that sodium, magnesium, aluminium. Okay, 14 one is silicon, phosphorus, sulfur, chlorine is increasing. 11, 12, 13, 14, 15, 16, and 17. There is argon as well, 18. So metallic character, these are metals, these are non-metals, decreases. Number of electron shells, they have same number of valence shells in the same period. Reactivity of the water, These react with the water explosively. This with the stream it reacts. Okay, and then in this way their reactivity decreases. So basically, this is also wrong. Ability to form anions. Of course, these are the cations. The ability to form the cations is decreasing. Okay, and ability to form the anion is increasing. So this is the correct option. The melting point of lithium is 181. The melting point of the sodium is 98. Which statement explains why lithium has the higher melting point than the sodium? What's the reason? Lithium and sodium. Lithium and sodium. Lithium has more valence electron than sodium. No. Both have the same. Sodium is more reactive than lithium. This is correct, but it has no concern with the melting point. Okay. From top to bottom, reactivity increases, but it has no concern. Now let's see with the melting point. Okay. Sodium is softer than the lithium. It also has no concern with the melting point. Attraction between the positive ions and the sea of electrons is stronger in lithium than the sodium. Yeah, of course. This is the thing. Okay, the higher melting point is because of the high metallic bond, and the high metallic bond is because of the greater attraction between the sea of electrons and the positive ions. So that is possible in case of lithium than the sodium. That as compared to sodium, in the lithium the attraction is stronger. Okay, so option B is correct. These statements are good, are accurate, but they have no concern, they have no relation with, they have nothing to do with these statements, with this question, okay? They cannot help out to solve these questions. From their position in the periodic table, which properties would you expect the elements vanadium, chromium, and cobalt have? They are all transition elements. They have variable oxidation states, it's okay. Color compound, it's okay. High melting points, that's also okay. Okay, vanadium, chromium, and cobalt. So A is okay because they are the transition elements. So all these features are belong to them. Okay. The diagram shows the structure of an alloy. We have structure of an alloy. Which statement about alloy is correct? Alloy can only be formed by mixing copper or iron with other metals. No, you can mix other things as well. High carbon steel alloys are soft and easy shaped. Yeah, we can say like this. West about the alloy is correct. Okay. In an alloy, there is attraction between the positive ions and a sea of electrons. High carbon steel are soft. No, these are not soft. When there is high carbon, so these are hard, brittle. Okay. In alloy, there is attraction between the positive ions and the sea of electrons. Yeah, of course, this is okay. The brass has the chemical formula. Brass has no chemical formula because this is the alloy and this is the mixer, and mixer have no formula. In an alloy, there is attraction between the positive ions and the sea of electrons. Of course, when the metals combine, okay, so their physical properties are not changed. They have the metallic bond. Okay. Sorry, their physical properties, I mean to say that when the metals combine, so attraction between the positive ions and sea of electrons, which is the metallic bond, that is not destroyed. They are not going to make the covalent bond, they are not going to make the ionic bond. Then okay, this is the metallic bond, and metallic bond has the same feature. Okay, so when the metals combine, their physical appearance may change, their strength may change, but the attraction between the positive ions and sea of electrons is not changed. So that's why option C is correct. The list shows the position of metals in the reactivity series of the metal. Which metal could be used to extract metal X? Electrolysis of this solid metal oxide. Okay, we have to see here that electrolysis, aluminium, no, after aluminium, those are not used by electrolysis. Okay, so this is not till aluminium we can separate by electrolysis. Okay, but iron we separated by reduction with the carbon. Okay, so it is below the iron, so that's why it is also reduction with the carbon. Heating the metal oxide with carbon, yes, this is possible, this is okay. Heating the metal oxide with copper, metal oxide with copper, heating metal oxide with copper. But copper is least reactive, it is inert. Okay, this is inert, so that's why it doesn't take oxygen easily. So that's why we mostly use, that we use carbon or hydrogen. Okay, so these two gases are used, and by heating them they can get oxidized, and in this way other can be reduced. So two only. Okay. An old commercial process of aluminum extraction used large quantity of sodium to convert aluminum ion into aluminum atoms. Sodium was used to convert the aluminum ions into aluminum atoms. Modern aluminum extraction process uses electrolysis. Which statement are correct? In all process, sodium acted as the oxidizing agent. Let me see that what happens. Aluminium extraction use large quantity of sodium to convert the aluminum ions to aluminum atom. Aluminum ions Al plus 3, okay, and 3 electrons are given by the sodium and it becomes aluminum. Okay, aluminum ions are converted into the aluminum atoms. So gaining electron, what it is called? It's reduction. Okay, and reduction is done by the reducing agent, not by the oxidizing agent. Okay, sodium is not oxidizing agent, it is the reducing agent. The reaction worked because the sodium is more reactive than the aluminum. Sodium is more reactive than the aluminum. This is almost okay. Okay. Next is the equation for the cathode reaction is Al plus 3 electrons, and this is liquid, sorry, not because this is at high temperature, it's okay. The carbon anode needs replacing often because it is oxidized to carbon dioxide by the oxygen evolved. Yeah, of course, when the electrolysis takes place, so oxygen is also evolved from the other side, so carbon is oxidized by the carbon to form the carbon dioxide. This is also okay. 2, 3 and 4. Okay, 1 is not correct. 2, 3 and 4. Okay, it has to be reducing agent instead of oxidizing agent. Which element is always present in steel? Iron. Okay. Aluminum is used to make pans because of its apparent lack of reactivity. Which property of aluminum explains its unreactivity? It has a layer of oxide on its surface. Yes. It has low density. It has no concern with the reactivity. A good conductor of electricity, then it should react. Okay. Group 3, it doesn't matter if it belongs to group 3. Whichever group is there, actually it is surrounded by oxide layer, so further its reactivity is decreased. Okay, it becomes unreactive. Pollutant gases are released by the bacterial decay of the vegetable matter. The bacterial decay of vegetable matter is the main source of which gas? Which gas is produced by the bacterial decay of vegetable matter? Carbon monoxide? No. Methane? Yes. Unburnt hydrocarbons, these are. And nitrogen dioxide at high temperature they are produced. Sulfur dioxide, they are by burning they are produced. Okay, by burning. And methane is produced by the biochemical decay. Okay, large alkanes are converted into small alkanes like this. Okay, and this is formed methane. Lakes contain a variety of dissolved substances. Which substances is responsible for eutrophication in the lakes? Eutrophication means the covering of the lake with the with the increased production or high amount of the Lg. Okay, so basically metal compounds, no. Nitrate fertilizer, yeah, of course. When the nitrate fertilizer is used in excessive amount in the fields, that is taken by the rainwater, and in this way the growth of algae is increased in the water bodies, and the water surface of that water body is covered by the excessive amount of algae. In this way, nitrate fertilizer is useful, and this is called the eutrophication. Not oxygen, not sulfuric acid. How many of the molecules shown belong to the homologous series of alkanes? Alkanes means the CnH2n plus 2 means the number of hydrogen are double from the carbon. C2HO4, no, only double, not more than, not two more than the double. Okay, so this is the CnH2n, this is alkene. 6m plus 2 8, this is okay. 4 8m plus 2 10, it's okay. 5 and 10 just double, this is the alkene. 6 and 6 it becomes 12 plus 2 14, this is also okay. Means 2 more than the double as compared to the carbon. Okay, so 3 are there. Option C is okay. The diagram shows the structure formula of an organic compound. You can see the organic compound. The statement about this compound is correct. It is saturated hydrocarbon. It's okay. This is the saturated. It's an alkene. It can never be alkene because it doesn't have the carbon-carbon double bond. Okay. It's an isomer of butane. If it has to be an isomer of butane, so why it is in this form? So butane, what is the formula of butane? C4HO10. Okay. 1, 2, 3, 4, C4, but H 1, 2, 3, 4, 5, 6, 7, 8. How can it be isomer? It doesn't have complete number. It doesn't have the same formula. Okay, so it is a cyclic. It is something else. It will undergo addition with the hydrogen. No addition, because for addition reaction there must be carbon-carbon double bond. Okay, so it is saturated hydrocarbon. Yes, it is saturated hydrocarbon. Let's stream about the vegetable oil and the margarine made from it is correct. Both are liquid at room temperature. No. Both occur naturally. No. One is artificially made, means one is synthetic. Okay. Margarine has high melting point. Yeah, this is the correct. Vegetable oil has the fewer carbon-carbon double bonds than the margarine. Means fewer means less number of carbon atoms, carbon-carbon double bonds. But it means the margarine has but more, and vegetable has carbon-carbon double bond fewer. So it doesn't mean to us. Okay, it is not correct. Okay, so margarine has the higher melting point. It's okay. Margarine, actually we have oil and then we use hydrogen in the presence of nickel, and then margarine is formed. Okay, at room temperature this is the liquid, at room temperature it is the solid. So that's why it has high melting point, because it is solid at room temperature. Which group is found in alcohols? This group is found. An ester is formed from a carboxylic acid and an alcohol. How does the number of carbon, hydrogen, and oxygen atom in an ester differ from the total number of these atoms in the carboxylic acid and alcohol from which the ester is formed? Let me tell you what is ester. Suppose we have I'm writing here carboxylic acid, CH3, C double bond oxygen, OH, plus OH and then C2H5. From here H and from here OH. What we get? CH3 minus H2 is released. Okay, CH3, C double bond oxygen. This is ethanoate ion, and this is ethyl ethanoate. So carbon atoms are same. Carbon atoms are not decreased. Okay, hydrogen atoms are fewer. Hydrogen atoms are really decreased, and oxygen is also fewer. Not same. Hydrogen are not same because water has to be released, so oxygen also has to be released in the water. So C is correct. Which statement about the composition of polymer is correct? Nylon contains oxygen atom but not the nitrogen atoms. No. What is nylon? Nylon, how is it made? What is nylon? Nylon is made from diamine and dioic acid. Dioic acid plus diamine. Okay, I'm writing it quickly. C double bond oxygen OH 1 carboxylic acid, and here is diamine means nitrogen. It has hydrogen, two hydrogen, but I'm writing here separately. Okay, you can see OH from here and H from here. H2 will be released. Nylon contains oxygen atom but not nitrogen atom. It has nitrogen atom. Proteins contain both nitrogen atoms and oxygen atoms. Proteins contain both nitrogen atoms and oxygen atoms. It's okay. It's okay. Pterylene contains nitrogen atoms. Pterylene. What is pterylene? Pterylene is polyester. There is no polyester. Okay. There is no nitrogen. The polymer used to make cling film contains oxygen atom. No. So what is protein contains both the nitrogen atoms and the oxygen atoms. So what is the monomer of protein? Let me just tell you, protein is the building block. Protein is made from the amino acids. Okay, amino acids are the building blocks of proteins, are building blocks of protein. What is amino acid? Carbon, alkyl group, COOH, hydrogen and NH2. Amino and acid both are in the same molecule. This is amino acid. It has amino group and acetic group. So that's why it is called amino acid. These combine. So hydrogen will be released from here and OH from here. Okay. In this way H2 will be released. But there is oxygen as well and nitrogen as well. Okay. Contains the oxygen and nitrogen both. So option B is correct. Polystyrene. Polystyrene is an additional polymer. Partial structure of polystyrene is shown, you can see here. What is the formula of monomer from which polystyrene is made? We have three steps. Identify the repeating units H and C6H5, H and C6H5. It means this is the repeating unit. Okay, HO, carbon HO, carbon C6H5, H and its bonds. Okay, so this is the repeating unit. So we have identified the repeating unit. Okay, and after identifying we have written it separately, and now convert the single bond into double bond means this. So third step is, first is identify the repeating unit, we have identified. Second is write this separately, we have written it separately. Third is convert the single bond into double bonds. So hydrogen, carbon, hydrogen, double bond, carbon, C6H5 and hydrogen. Is there any structure like this? No, it has to be converted into the double bonds. Wrong. Yes, this is the option. Okay, this cannot be repeating unit. Okay, the same is coming here. No, this can never be. No, there is no consecutive these 6H5 groups. Okay, this is the answer.